Hello and welcome to REGO-FIX Tech Chat. My name is David McHenry. I am the Engineering and Technical Manager here at REGO-FIX USA. One of the most common questions we get is, if I have to stack my tooling up, what TIR can I expect? Well, that's really a complicated question, but let's move over to the workbench, let's put an assembly together, and let's talk about the results. We've brought all of our tools over to our workbench, and we're going to use our Torco block to do our assembly. Now we're just going to kind of do a little fast-paced version of this. We're going to use the Torco block. I have my ER16 and ER32 rings. I have my MX wrench and my wrench for my ER32. So let's do the assembly. All right, let's get some measurements. Now that we have our tool holder fully assembled, I've gone ahead and I've taken a scale and I've marked 3 times D out for the base tool holder and 3 times D out for my pin at the end. Now the pin at the end is 1/4 inch, my base tool holder is 3/4 of an inch. So let's take a look and see what happens as we measure this tool, and we get the different locations and we see what happens with that TIR. So we have our tool assembly in our 0 spindle, and we've got our indicator set up. So let's measure the base holder with the extension in it to get an idea of what this part of the assembly is. Now remember, this is a regular ER collet, this is not a UP collet, so we shouldn't expect UP results. So let's take a look. So if we start rotating the collet or tool holder, you can see that about 1.5 on that side and about 3.5 on that side. So not bad, a maximum of 5 microns TIR with a non-UP assembly. Not too bad, really. So 5 microns at 3 times D on a 3/4 inch shank, we'll take that all day long. But what happens up here at the very top? So let's actually now move all the way up to our 1/4 inch cutting tool and see what we get on that assembly. We have moved our indicator all the way out to our 1/4 inch pin, and we are 3 times D or 3/4 inches from the face of the nut. So remember, it's a regular collet, it's a regular ER extension, it's a regular collet, and it's just a carbide pin. So what do we end up with on a stack up like this that you would see in your machining center? So let's take a look. And remember, these are regular collets. And let's see, get a couple good rotations on this. And really right around that 10.5 to 11 micron range, that's not that bad for as far out as we are. Remember, these are regular collets, and a regular collet actually has a call out of 10 microns, and we are just barely over that with 2 collets, 2 tool holders, and a carbide pin in the end. That's not too bad. So anything in that range, I think most shops will be very, very happy with getting that kind of run out. And you could sit here and you could tweak this in by rotating the collet or rotating the carbide pin to try to eliminate or reduce the amount of TIR. One thing to keep in mind is what we call compound TIR. That's what starts down here in the spindle itself and is carried all the way through and triangulates as you leave the spindle. Now, this 0 spindle is very good. We'll actually put the master bar in here in a moment and show you just how good this particular one is, so you know that we really don't have any influence from our 0 spindle that we're seeing in here. But remember, TIR from the base holder is triangular, it goes all the way out, so it adds to whatever you have on the assembled extension. So as mentioned, we went ahead and put our master bar into our 0 spindle just as a little peace of mind for those watching to kind of understand we're not adding much from our zero spindle. So we have our master bar in and start giving this guy a rotation, and you can see that it's I think the max number I just saw there was around 1.5, but it's literally 1 micron to 1.5 microns TIR at this distance. That's the master bar tolerance and the tolerance of the zero spindle altogether. So the numbers we're getting and showing are fairly accurate. As you can see, the numbers you get when you're assembling your tools in a stack-up, they can vary a little bit, and they're very dependent on the col that's used, the type of tool holder shank that's being used, and your cutting tool at the end, as well as what your original spindle runout is, because that all affects the overall result. Now, we had very good numbers with our ER assembly. This works for a large majority of our customers. But when you have the applications where you need a permanent long tool holder, don't forget about the XL program. These are available in ER and power grip options, and we have lengths now up to 840 millimeters in length, so we can get the reach you need for your application. If you have any questions at all about stacking tools up or the XL program, please reach out to your REGO-FIX technical team. We're here to help.